Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Calculus series and concerns stationary points. This guide describes the different types of stationary points, maximums, minimums and points of inflection which a function may have. It also explores how the first derivative is used to locate stationary points. Introduction. In the application of mathematics, it is often extremely useful to know the point at which a function gives its highest or lowest value. For example, if a function describes the variation of profit for a company with respect to how much of a certain good it produces, it would be useful to know the amount of good production which yields the most or maximum profit. Similarly, which dosage of a drug produces the smallest or minimum chance of contracting a particular disease. In mathematics, maximum and minimum points, along with another type of point called a point of inflection, are given the collective name stationary points. They can be found and categorized using calculus. More specifically, the first derivative of a function is needed to locate them, and the second derivative is used to find what type they are, known as their nature. Take this graph. From A to B, the gradient is downhill and getting less steep. B is a point of inflection. From B to C, the gradient is downhill and getting steeper. C is a local minimum. C to D, the gradient is uphill. D is a local maximum. From D to E, the gradient is downhill. E is a minimum. From E to F, the gradient is uphill and getting less steep. F is a point of inflection. And from F to G, gradient is uphill and getting steeper. To get the most from this guide, you should be familiar with the idea of a function and be comfortable differentiating simple functions. If you are not, it is recommended that you read the study guides using functions, what is differentiation, differentiating y equals ax to the power n, and differentiating basic functions. The remainder of this guide refers to the diagram on the first page. Stationary points and gradients. Differentiating a function gives its gradient. Any points on the graph of a function which have a gradient equal to 0 are important. Here, the slope of the graph is neither uphill nor downhill. In other words, these are the only points where y is not changing as x changes. The points at which the gradient of a function is 0 are called the stationary points of the function. In the diagram on the first page of this guide, the function has a gradient of 0 at points B, C, D, E and F. As you can see, as the function is given by y equals f of x and the gradient of the function is written as dy by dx, mathematically you may think of stationary points as solutions to the equation dy by dx equals 0, where the derivative is usually also a function of x. Each individual solution of the above equation corresponds to the x-coordinate of a point on the graph of the function y. Substituting each solution in turn into the original function gives the corresponding y-coordinate. The combination of x and y coordinates gives the location on the function graph that corresponds to the stationary point. See study guide Finding Stationary Points for details on how to carry out these calculations. Nature of stationary points. There are a variety of points on a graph where the gradient of a function can be 0. Perhaps the most obvious points are located either where the function changes from increasing to decreasing, the corresponding function graph changes direction from uphill to downhill, or from decreasing to increasing, the graph changes from downhill to uphill. These types of points are sometimes called turning points. Not so obviously, a graph can have a gradient of 0 where the function is increasing or decreasing both before and after the point. These types of stationary points are called points of inflection. 1. Maximum points. A stationary point where a function changes from increasing to decreasing and its graph changes direction from uphill to downhill as x increases is called a maximum point. A maximum point is also a turning point. Point D on the graph is a maximum point. Before the point, from C to D, the graph is uphill, and after the point, from D to E, the graph is downhill. Maximum point at D, increasing from C to D, decreasing from D to E. The function itself is increasing from the left and decreasing to the right of a maximum point. Maximum points come in two forms. 1. If the maximum point corresponds to an output that is the highest of all the outputs of the function, you can say that the function has simply a maximum at this point. The output is the maximum value of the function. 2. If the maximum point does not correspond to the highest output of the function, you can say that the function has a local maximum at this point. The output is a local maximum value of the function. Point D is a local maximum. You can think of maximums as corresponding to the location of points on the top of any hills in a graph. A maximum describes the top of the highest of these hills, if it exists. The tops of all the other hills are local maximums. A function may not have any kind of maximum points, or it may have, such as the graph on the first page of this guide, one or more local maximums without having a maximum. 2. Minimum points. A stationary point in which a function changes from decreasing to increasing and its graph changes direction from downhill to uphill as x increases is called a minimum point. A minimum point, like a maximum point, is also a turning point. Points C and E on the graph are minimum points. The graph is downhill before each point, from B to C for point C and from D to E to point E, and uphill afterwards from C to D for point C and from E to F for point E. C and E are minimums. The function is decreasing before the minimum point and increasing after the minimum point. The function itself is decreasing to the left and increasing to the right of a minimum point. Minimum points come in two forms. 1. If the minimum point corresponds to an output that is the lowest of all the outputs of the function, you can say that the function has simply a minimum at this point. This output is the minimum value of the function. Point E is a minimum point. If the minimum point does not correspond to the lowest output of the function, you can say that the function has a local minimum at this point. The output is a local minimum value of the function. Point C is a local minimum. You can think of minimums as corresponding to the location of points at the bottom of any valleys in a function graph. The minimum describes the bottom of the lowest of these valleys, if it exists. The bottoms of all the other valleys are local minimums. A function may not have any kind of minimum points, or it may have one or more local minimums without having a minimum. 3. Points of inflection. Points of inflection are stationary points which are classified as neither maximums nor minimums, but they do have a gradient of 0 nonetheless. In these cases, a function continues to increase or decrease near to the point, but a graph with a positive gradient may level out and become horizontal before continuing uphill. An example of this can be seen at point F on the graph, on page 1 of this guide. Both before and after this point, the graph has a positive gradient, but at the point F itself, the gradient of the graph is 0. Point F is a point of inflection. the function is uphill both before and after point F. Similarly, a graph with negative gradient may level out and become horizontal before continuing downhill. An example of this can be seen at point B on the graph on page 1 of this guide. Both before and after this point, the graph has a negative gradient, but at point B itself, the gradient of the graph is 0. Point B is a point of inflection, and the graph is downhill both before and after point B. Further guidance and information. If you have any further questions about calculus or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of calculus, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.